Practice problem on projectile motion. On the game opening kickoff, Steven Gostkowski kicks the football 65 yards, or 59.44 meters, for a hang time of 4.52 seconds. What is the initial velocity of the ball off his foot, and what is the maximum height achieved by the ball? Let's take a look at what's going on. So here, Gostkowski kicks the ball off the 35-yard line, up into the air, and it's caught by someone in 5 yards deep in the end zone. So that's a distance of 59.44 meters in a time of 4.52 seconds. Now let's think more about the physics of the kick. Otherwise, when it moved up into the air, it was moving up at an angle relative to the ground and had some horizontal and vertical motion. Let's sketch those velocity vectors. Here is the initial velocity vector relative to the ground at some angle. Let's call that angle theta. And again, this is VI. Here's the horizontal velocity, or Vx. And here's the y velocity vector, or Vy. So Vx vector plus the Vy vector up will add together to figure out our true initial velocity and angle. So let's do it. Our given information here is a distance of 59.44 meters in 4.52 seconds. From physics, we know that the horizontal velocity is constant and given by distance over time, the definition of velocity. Let's calculate Vx. Pause and do it on your own. So dividing those numbers gives me 13.15 meters per second. Now let's take a look at Vy. So for the vertical motion, we know that there's an acceleration in the y direction by gravity, which is negative 9.8 meters per second squared, thus changing the velocity in the y direction over time. So at that acceleration rate, I know Vy at the peak is 0. Compared to the initial Vy, it's going to take half the amount of time to get to the peak. So from doing this, I can derive a relationship for Vy, which is 9.8 times delta t over 2, where t is the full hang time. Well, we know that's 4.52 seconds, so let's see what we get by substituting. Pause and try it on your own. So this gives me a y velocity of 22.15 meters per second. Now that I know Vx and Vy, I can use Pythagorean theorem to find Vi and sine, cosine, or tangent to find the angle. Pause the video and calculate these on your own. By doing that out, Pythagorean theorem, I get Vi squared equals Vx squared plus Vy squared. When I add these squares and take the square root, I get initial velocity of the football off of his foot as 25.76 meters per second. Now for the angle. If I apply the definition of tangent, that's opposite over adjacent, or Vy over Vx. So 22.15 divided by 13.15 is 1.68, but that's the tangent of the angle. So to determine the actual angle, that means the angle is going to equal the inverse tangent of 1.68. Make sure your calculator is in degrees, and you'll get an angle of 1.68 inverse tan. I got 59 degrees. Now what about the maximum height achieved by the ball? Here we can see that the football follows a parabola. So we want to know the time it takes to reach the max height. Well, that's just half the total time from kick to peak. That will give us 4.52 seconds as the true hang time divided by 2, or 2.26 seconds to the peak. Now to find that max height, we can use this relationship, but analyzing it purely vertically, meaning that this will be a vertical height, this will be a vertical velocity, or Vy, this will be a vertical acceleration, or negative 9.8 meters per second squared, and this time will be the time to the peak. See if you can put in the correct values and solve for the max height. Hit pause now. So by substituting Vy as 22.15 meters per second Acceleration is negative 9.8 meters per second squared, and the time to the peak is 2.26 seconds. We get a height of 25.03 meters, which is about 82 feet. Thank you for watching, and see you in class.